Welcome back to Ox Tools. I'm Tom. So today we're working on the drive hub for the etching press. And this is part of the Wabble gear reducer for the large etching press that I'm working on. I ordered some steel recently, some flame cut stuff, some different small components that I can work on and kind of move the project forward. My goal is to set up the drive system and actually test that on the bench. So I've ordered some bits and pieces for that so that I can finish that and bench test it and get warm and fuzzy with that. So with that, let's go take a look at this drive hub, and we'll take a look at the steel that I had burned out, and let's get going. Okay, so here's the drawing and the blank for this the input hub for the Wabble on the etching press. So this is a cross section here. Actually, I didn't. Bad draftsman here didn't draw the cross section lines here. Oops. Okay, so there's the cross section. So we've got two bores and then a step for the spider to attach to. So let's get to work. This is a pretty straightforward part here. Nothing super fussy there, and but you know, it's got a fair amount of material to remove. So let's get started. All right, boys, we got steel in the house today. So I got my delivery from Knoll Steel. And I sent them some DXF files for some burnouts here. These are etching press related. This is part of the Wabble Drive. This is part of the Wabble Drive, and then these are the main bearing housings, the moving bearing housings. This is for the arbor press. This is a new base plate for the arbor press. I figured, hey, what the heck? While I'm having them burn some 1.5 inch, I'll have them do a new proper. I don't know, platen for the arbor press. So that's kind of a separate project. So let's do the bearings. So this is the main bearings here, and so these will get bored for these big guys here. And then they have a guideway on the side and a spring counterbalance, and then a lift mechanism. So there's a bit of work in these guys here, and we'll get going on those pretty soon. And you guys have seen the Wabble gear here, right? Well, this is the input spider that we're also working on the hub for in this particular video. The input hub attaches to this, and this connects it to the main shaft. So let's see here. This will be actually behind there like that. Okay, that'll sit like that. And actually our little, well, let me grab it. Ultimately our little thrust washer will sit in this area here. So you can kind of see, I got steel here, right? And I didn't want this steel, that opposite side, rubbing on any of this. Since there's a differential rotation there, I didn't want them rubbing on that. So that's why I have that's why I made that bronze washer. So anyway, that's kind of the deal. And these are just so cool looking, I just got 2 of them. So just in case I bozo this one. So anyway, let's get cracking here. We got plenty of material now, and we got drawings. We're good to go. Okay, so let's open this sucker up for our big blank. All right, there's that. So we're going to use this backing plate, and I've already set the spacing there. And this gives us something to push against here. So initially we're going to, we'll face this off, and then we're going to, I think I'm going to do this backside bit first here. turn that step, and then I'll hold it by that step to do the rest of the work, I think. At least that's what I'm thinking right now. All right, so let's put a little grunt on that. Use my A-bomb approved knocker there. All right. So all this is going to get turned, so there's no surfaces that are going to remain here. Let's see, this is what, 5-inch diameter? Let's see, we want 300 R. Yeah. Looks pretty good. All right, and we're going to use my WNMG with a PP chip breaker here. This is a ISCAR tool. I really like it. It's pretty versatile, and it's a low cutting pressure. So it's a negative insert, but it's low cutting pressure. So let me change the camera around a little bit so you guys can see better here what's going on, and then we'll start chipping away at this thing. Okay, so let's get started here. Change the feed direction there. So we'll start by facing it. The blank's a little bit long. Come back out. finish on there coming in this direction, so that edge of the insert, the edge, the turning side of that insert must be a little bit dull because it's leaving a real kind of a lousy finish there. We'll come back in. Well, it's pretty smooth, but it's not very shiny, that's for sure. So I want to redo it? I don't know. Oh, you know what? This side gets faced again later on after the spider's welded to it. So I think I'm just going to leave that and call it quits on that. And then, so while I'm here, I'm going to drill in a little bit and get that part going. Now, I'm not going to drill all the way through because I got to come in from the other side, and if I don't need to poke my backing plate, I won't. Now you'll notice that I didn't drill a pilot hole. This is about 7/8 drill, something like that. You know, and they call it work for a reason, right? All right, a couple more. All right, that's probably good. Now we're going to come up, we're going to calibrate our tool for turning. Let's see, am I going the right way? Yeah, I'm going the right way. Okay, so I'll turn enough to get the micrometer on it. And then we'll take a measurement. Nine and 75. Okay, so that's 4.975. Enter. Okay, and you know, just to make sure you don't make a bozo. Yeah. Okay. So now we'll dig into that a little bit. I'll change the camera because this segment's getting a little long. Okay, so we're running, what are we running? 285 RPM, and it's about 125 thousandths on the diameter depth of cut, and 8 thousandths per rev feed rate. So, which is about 0.2 millimeter per rev, and we're about what, 3 millimeters on the depth of cut on the diameter, 3 to 4 millimeters on the depth of cut. So, you know, reasonably efficient cutting setup, leaving a nice finish, it's stable. So if you examine the chips, let's see here. So if you examine the chips got some color to them. That means the heat's coming off in the chip. The chip is a good indicator as to what's going on here. Let's grab a little handful down here. Okay, so they're tan to blue, which is good. So that means you know, you're pretty close on the cutting speed. And what? I don't know. Let's keep going here. On this diameter here, and then we'll work the bore a little bit, and then we'll do all the finish at kind of at one time. So. We're facing that face there. Yeah, we'll take out all the steps. There's still some meat on that surface, so you can hear that noise. So that's the chip thickening up as it encounters each one of those turning steps. Okay, all right. Okay, so we got a boring bar here. Let's get the tool calibrated here. Okay. Pretty good. Let's take a little test cut. Alright. Just want to have a rough calibration on the tool. Alright, it's about 940. Okay, and that way I can kind of know when I'm getting close here. All right. Okay, so I don't really care about the finish right now. you know, I'm just trying to remove that material as quickly as possible and get close to my bore, and then I can do the fine boring from there. So I'm not too concerned with finish right now. Things are getting warm. Okay, so we're pretty close now. Got a little bit left, about 30 thousandths something on the bore, and it's pretty warm right now. The tool's warm and the part's warm, so we're gonna let those cool off a little bit, and then we'll come in and we'll do the finished bore, finish that, and then I may just turn a little bit off of this as well, because that diameter's got to come down too while I'm set up. So anyway, that's where we're headed, and we'll come back for some finish work. Okay, so everything's nice and cool now. So we're going to do our finish bore. This is a 2-inch bore, about a 50 millimeter bore. It's not a precision bore, it's just clearance for the shaft that goes through it, but I want a nice finish, and I want it to be, you know, basically on size. Like I said, it's not a super precision thing. This insert, I just looked at it under a magnifier, still looks pretty good, so I'm going to go with it for the finish cut, or finish cuts, I should say. But I'm going to slow the feed rate down a little bit. Okay, that's about half, so that's what, ECG. So that's about 4 thousandths per rev feed rate. So we'll get a little closer, make sure we got our good tool calibration. Yeah, that looks pretty good. Finish looks good. So we'll let that go, and then we'll take one more pass out of there after we get a measurement. Now the finish pass, I use a little bit of oil just to help the chip flow, and it's not so much to cool the cut, it's to lubricate the chip flow. That's really what I'm looking for there. See down there. Yeah, you can see pretty good, huh? 6, 7, 8, 4. At the bottom of the hole. Okay, I'm going to come out. Now you see, when I backed it out, it left a little mark in there. That's okay on this pass, but on the finish pass, we don't want to do that. We want to come into the bottom, and then we want to come out a little bit so that the tool flex doesn't leave a track in it. So and this is this caliper dimension for this particular bore here. Alright, so we're 989, okay. Let's reset our DRO here. 1.9889, enter, okay. So we're just going to go to our finished 2-inch, and should I move the camera? I don't know, that's a pretty good shot, so let's go with it. Okay. Alright, that looks pretty good. Let's see what Mr. Calipers tell us. Oh, that's 2-inch. I don't know, can you see that? Finish looks good. Okay. So that's that. Now we'll switch over to the turning tool and we'll finish that, and we're going to take a little off of that too. About a thou under, something like that. That's okay for that. Alright, I think I'm going to rip off a little bit up here and then throw some chamfers on this. You don't need to see that. And then we'll flip it around and we'll start working the other side. Okay, so this should be our finished pass coming up here. I'll show you guys what fits in here after we get this to size. It's the drive hub, commercial drive hub. Just hand feeding it across the bottom. a nice finish in there. Okay, so let's get a measurement here. I call it PFC. So that's 3-inch 150. That was the target. So we're looking good. All right. So chamfer a couple edges here. I gotta go find a tool that I can reach down in there with, and we'll try the hub. Okay. So here's the. This is a special kind of a tapered bushing. It's called a keyless bushing. You don't need a keyway, and it'll transmit all the driving force for this hub. So that sits in there like that. So this wobble reducer transmits power to this, and then this locks to the hub and to the shaft that goes to the main roll. Okay. Anyway. That's how that works, and that's how that fits. Okay, so that hub's kind of done. I think I'll do a little polishing on the outside, and then we'll get to work on the spider. Okay, so here's the hub we just made, the Wabble Drive Hub, and this is the Wabble spider here, and this is the commercial Trend Torque or B-lock. Anyway, this bore here needs to get opened up to fit that. Okay, and then that goes in here like so, and then this attaches to the main wobble gear. And so next up is this guy here. We're going to turn the OD. We're going to bore that. We're going to put a bolt pattern in this to attach it to the wobble gear, the output gear, and then we'll probably do a little bit of handwork. I'm probably not going to fully round these. I'll just deburr this, or maybe I'll take a facing cut on it if it doesn't hum and it's stable. But that's next up. So thanks for watching. Stay tuned for the next step on the etching press.